Fifth question says a steady state one-dimensional conduction occurs in a rod of constant thermal conductivity. So K is constant, K is not varying. ठीक है, K is constant. ठीक है, and variable cross section area, that is important, which is given as AX is equal to, जो आपका cross section area means the direction in which heat transfer is taking place, perpendicular to that direction the area we have to take, and that area is not constant. That is a function of x, where x is the distance in the direction of heat transfer, and that is given as Ax is equal to A naught into e raised to the power minus x or x, right? Where A naught and A small a are constant. The length of the rod is capital L. So length is capital L. ठीक है. K is constant. The lateral surface of the rod is well insulated. It means only axial direction heat transfer. Only axial direction heat transfer. ठीक है. Lateral surface insulate होने का मतलब है कि radial direction में कोई heat transfer नहीं हो रहा है. देखो इसको rod बोल रहा है and still this rod is not cylindrical. Normally the rod word is used for a cylindrical body, but this is not cylindrical. This is a variable area body, right? Only axial direction heat transfer. So ये जो shape है rod का, ये कुछ ऐसा है. Exponential है ना? Exponential increase in area. So something like this. This kind of shape is there. Okay. The length is equal to L, and cross section area, you have the relation, and this is the direction of heat. This is the axis, correct? And this is the direction of heat transfer. This is given. K is constant. The surfaces at x is equal to 0. This is at x is equal to 0. This is x is equal to L, are kept constant at a temperatures of T1 and T2 respectively. So this temperature is T1 and this temperature is T2. Fine. Find the expression for the temperature distribution in the rod and the rate of heat transfer through the rod. Now what do you think? The rate of heat transfer through this rod will be constant or will be changing, will be a function of position? What do you think? Because in this case, the area of cross section is not constant. ठीक है, अब area of cross section constant नहीं होने से, and we have steady state. I told you that whenever we have steady state, always the rate of heat transfer or rate of any transport is constant, but the flux is not constant. है ना? Steady state का मतलब rate constant है. Flux constant है कि नहीं? That depends upon area, because flux is rate by area. Now in this case, as you go from x is equal to 0 to x is equal to L, you can see that the area is increasing and therefore the flux must decrease. ठीक है? So we have to find the expression of flux as well as the expression of the temperature profile as a function of x. ठीक है? It is very clear that only conduction is taking place, thermal conductivity constant, so of course the Fourier law can be well applied. So Q is equal to minus negative sign को भूलना नहीं है, minus K. K is constant, right? And multiplied by A. What is A? A is A naught into e raised to the power ax, and that multiplied by dt by dx. That is the Fourier's law of conduction, which is applicable for steady state heat transfer. Now this expression will be dt is equal to variable separable type की differential equation में बनाना है इसको, है ना? Separate it. Q divided by dt is equal to Q divided by or minus Q divided by K A naught into e raised to the power ax dx. Is it okay to write like this? Okay. K naught e raised to the power ax into dx, right? So that becomes, in this case, I can also write this e raised to the power ax as e raised to the power minus ax, है ना? I can write like this so that easier for me to integrate. आप e raised to the power x लिख के भी integrate कर सकते हो. Of course, k is constant, a naught is constant, which is given in the problem. Okay, so I have to integrate this as a function of x. So you know that at x is equal to 0 and at x is equal to L, what will be the situation? Let's see. Q will be constant because we are dealing with steady state heat transfer. Since steady state heat transfer is there, since steady state heat transfer is there, heat transfer is taking place. Since steady state heat transfer is taking place, Q is constant, but flux is not. Please note, right? If Q is constant, I can integrate this dt and then minus Q by K A naught e raised to the power minus ax dx from when x was 0, temperature was T1. When x was L, temperature was T2. ठीक है, तो वेरिएबल एरिया के लिए मैंने आपको कोई डायरेक्ट फॉर्मूला नहीं बताया. सो व्हाटएवर बी द सिनेरियो, दिस एरिया इज चेंजिंग एक्सपोनेंशियली. इन सम केसेस एरिया कैन बी चेंजिंग, पैराबोलिक चेंज कैन बी देयर इन द एरिया. इन सम केसेस देयर कैन बी अ लीनियर चेंज इन एरिया. Okay, so let us integrate this. And what is the integral of this equation? It will be dt will be t2 minus t1, right? And this is q dt, right? So okay, t2 minus t1 is equal to minus q by k a naught, right? Minus q by k a naught. 0 to L. What is the integral of e raised to the power minus ax? The integral is e raised to the power minus x divided by minus a, right? So that minus and this minus will be cancelled, and a is constant, we know that, so that a will be taken here, and this will be becoming minus e raised to the power minus ax, right? So if you put the limits, e raised to the power minus al, right, and minus 1. Fine. So t2 minus t1 is equal to q by ak naught into e raised to the power minus l minus 1. That can also be written as q is equal to, if I want to write this as a driving force by resistance, I'll write this equation as t1 minus t2, right, divided by 1 minus e raised to the power minus al divided by ak a naught. That is the expression for capital Q. You can see that in the capital Q, I have already assumed that capital Q is constant because this is steady state heat transfer. All the terms are constant terms. And I have tried to write again the Q as T1 minus T2 is equal to this Q by driving force divided by some kind of resistance. Right? That is, and the resistance can be written as this is 1 minus e raised to the power minus L divided by ak a naught. Now, if you ask me about this temperature profile, how to obtain the temperature profile, nothing, no need to worry, and everything is exactly same. Just replace T2 with T, okay, and L with X. In that case, you will be getting an expression. Instead of T2, here it will be T, and here it will be e raised to the power minus X minus 1. है ना? So for finding the temperature profile, what you can do is just change the limits from t1 to t and from 0 to x and then integrate. ठीक है, तो आपके पास दोनों एक्सप्रेशंस आ गए. आपके पास रेट का भी एक्सप्रेशन आ गया और आपके पास टेम्परेचर का भी एक्सप्रेशन आ गया. ठीक है, मैं आपको एक्सप्रेशन लिख देता हूँ. एंड दिस विल बी फॉर टेम्परेचर प्रोफाइल. राइट नाउ फॉर टेम्परेचर प्रोफाइल तो कुछ था नहीं यहाँ पे, बस छोटी सी मैथमेटिकल इंटीग्रेशन. होता क्या है कि कई बार जब एरिया चेंजिंग होता है तो स्टूडेंट्स फूरियर्स लॉ लगाने में डरते हैं कि नहीं, फूरियर्स लॉ नहीं आ पाएगा. ऐसा नहीं है. यू हैव सीन बिफोर ऑल्सो इन द व्हेन देयर वाज अ सिलिंड्रिकल बॉडी, देयर वाज अ स्फेरिकल बॉडी, एवरीवेयर आई अप्लाइड द फूरियर्स लॉ. ओके, सो एरिया का फूरियर्स लॉ से कोई लेना देना नहीं है. वेदर एरिया इज कांस्टेंट और एरिया इज नॉट कांस्टेंट, यू कैन ऑलवेज अप्लाई द फूरियर्स लॉ. सो फॉर टेम्परेचर प्रोफाइल you have to just take slightly different limits, that integral of dt from t1 to t is equal to minus q divided by k a naught integral from 0 to x e raised to the power minus x dx. इतना करके इसको solve कर सकते हो. Exactly similar kind of result will be there. Instead of there will be some one variable y and one variable x will be there, so y becomes t and x is x, right? So this was again a problem. A slightly different problem based on the variable area, right? So again, these problems which I am taking right now, they are not from GATE. Okay, so I have selected these problems from various resources so that all the discussions, all the theory part can be discussed in these numericals. ठीक है? Okay. There can be various kind of relations. एक बार आपके केमिकल में भी गेट में क्वेश्चन आया हुआ है. You have a body whose sides are increasing linearly. है ना? अगर आप 90s के क्वेश्चन देखो, देयर वाज अ क्वेश्चन वेयर देयर वाज अ शेप, देयर वाज अ काइंड ऑफ डक्ट वाज देयर whose sides were increasing linearly actually, right? Whose height was increasing linearly. It's like here the duct height was this and here the duct height was linearly increasing. So there also you can use the same concept, but please note that if the sides are increasing linearly, it's not necessary that area will also increase linearly. तो कुछ जगह पे उसका सॉल्यूशन दिया गया है, मैं देखा है स्टूडेंट्स लेके आते हैं, वो पूरी तरह से गलत है. वहाँ पे एरिया में भी लीनियर रिलेशन मान लिया है. ऐसा नहीं हो सकता. इफ द साइड्स आर इंक्रीजिंग लीनियरली, देन साइड्स आर इंक्रीजिंग लीनियरली, नॉट द एरिया. Okay, so let us take the next problem, the problem number 6, which is saying that consider a 20 mm thick plate. So the plate thickness is 20 mm. Consider a 20 mm thick plate, correct, with uniform heat generation of 80 megawatt per meter cube. So Qg is equal to 80 megawatt. M for mega 10 to the power 6 per meter cube. The left and right phases are kept at constant temperatures. This problem I was talking about, that आपको एक concept मैं problem में explain करूंगा, that the left face is maintained at a temperature of 160 degrees Celsius with the help of some fluid or anything like any source, and the right surface is maintained, surface or medium surface, yeah, they are maintained at a temperature of 160 and 120 degrees Celsius. In the derivations, when there was a heat generation, I could took simple case where the two sides, the two directions of the wall were present in the same conditions. जो condition इस तरफ थी right side में, वही condition left side में थी, and this leads to symmetry. Whenever your conditions, all around conditions are same, the profile is always symmetrical. Okay, but when the temperatures on the two walls of this two sides of this wall are not same and heat generation is also same, heat generation is also taking place, of course the profile will not be symmetrical. ठीक है, तो यहाँ profile symmetrical नहीं होगी. आगे पढ़ते हैं. The plate has a constant thermal conductivity, so K is equal to 200 watt per meter per Kelvin. Units are also fine. Okay, many of you may ask, sir, these temperatures are given in Celsius and this is in Kelvin. ये वो सारे बच्चे पूछते हैं जिन्होंने हीट ट्रांसफर नहीं पढ़ी है. ठीक है, तो क्या यहाँ पे चेंज करना जरूरी है? Do I need to convert this 120 degrees Celsius into Kelvin? Do I need to convert this 160 degrees Celsius into Kelvin? Because K की जो यूनिट्स है वो केल्विन में दी हुई है. ठीक है, आपको पता है that K, Cp and H in the very first lecture I told you, ये तीन चीजें they are defined on the basis of delta T. अब आप टेम्परेचर के डिफरेंस को चाहे केल्विन में पढ़ो चाहे सेल्सियस में पढ़ो, डजंट मैटर. और आपको मैंने लिखवाया था पॉइंट दैट द वैल्यू ऑफ के विल रिमेन 200 वेदर यू राइट हियर केल्विन और सेल्सियस. तो अब ये टेम्परेचर अगर सेल्सियस में है तो यहाँ सेल्सियस लिख दो, कीप इट 200. ये टेम्परेचर अगर केल्विन में है तो यहाँ केल्विन लिख दो, कीप इट 200. डजंट मैटर. Whether you express the value of thermal conductivity in terms of degree Celsius or Kelvin, the value of thermal conductivity won't change. मैं फिर से याद दिला रहा हूँ, कई बार बच्चे अभी YouTube चैनल पे किसी ने कमेंट किया कि सर ये आपने केल्विन को सेल्सियस में क्यों नहीं बदला. ठीक है, तो आप हीट ट्रांसफर पूरी पढ़ लेते तो सारा हीट ट्रांसफर खत्म हो जाता है. फिर भी आपको ये नहीं समझ आता है कि मुझे कब केल्विन को सेल्सियस में चेंज करना है, कब चेंज नहीं करना. एटलीस्ट विद दीज 3 क्वांटिटीज. एंड ऑफ कोर्स फोर्थ क्वांटिटी भी आप बोल सकते हो U इज अ काइंड ऑफ H ओनली, इसलिए मैं U को साथ में नहीं लेता. ओवरऑल हीट ट्रांसफर कोफिशिएंट, thermal conductivity and specific heat capacity. All these things are defined on the basis of delta T and therefore their values won't change whether you write them in terms of degree Celsius or in terms of Kelvin. Okay, so no need to change the units of K or the units of these temperatures. Okay, so 200 watt per meter Kelvin is the value of K. Now the question says determine the location and the value of maximum temperature. मतलब आपको ये पता करना है कि जो मैक्सिमम टेम्परेचर होगा वो कहाँ होगा. ऑफ कोर्स दैट सपोज दिस इज योर सेंटर लाइन. ओके, इफ दिस इज योर सेंटर लाइन, यू नो दैट इन दिस केस देयर वोंट बी एनी सिमेट्री. तो मैक्सिमम टेम्परेचर सेंटर लाइन पे तो नहीं होगा. आइदर इट विल बी ऑन द लेफ्ट हैंड साइड ऑफ द सेंटर लाइन और इट विल बी ऑन द राइट हैंड साइड ऑफ द सेंटर लाइन. देयर आर वेरियस अदर पार्ट्स ऑफ दिस क्वेश्चन. वेरी गुड क्वेश्चन अगेन. सो द एक्सप्रेशन फॉर टेम्परेचर डिस्ट्रीब्यूशन तो निकालना ही है ना. द लोकेशन एंड द वैल्यू ऑफ मैक्सिमम टेम्परेचर एंड द रेट ऑफ हीट ट्रांसफर एट द लेफ्ट फेस, एट द राइट फेस, एट द प्लेट सेंटर पे रेट ऑफ हीट ट्रांसफर क्या होगी, लेफ्ट फेस पे क्या होगी, ये सारी चीजें आप कैलकुलेट कर सकोगे. द फर्स्ट थिंग इज यू नीड टू डिटरमाइन द टेम्परेचर प्रोफाइल. वट एवर रिलेशंस आई हैव गिवन यू, राइट, whatever relations I have given you, those relations for heat generations are not applicable here. Why? Because here there is no thermal symmetry. If you remember, I derived those relations by using the conditions of thermal symmetry. There is no thermal symmetry in these problems. फिर वो conditions हम यहाँ पे apply नहीं कर सकते. But yes, the general heat conduction equation, वो तो general conduction equation है, that is always applicable. The direction of heat transfer is this. ठीक है? So and one more thing, कि यहाँ पे symmetry है नहीं, तो सिमेट्री नहीं है तो जरूरी है क्या कि इसको मैं x इज इक्वल टू 0 लूं? नो, नॉट रिक्वायर्ड. सो आई कैन ऑलवेज टेक दिस एज x इज इक्वल टू 0, राइट. and this as x is equal to what I should write here, 20? No, because you can see here everywhere it is meter, and this is in millimeters. So 2 or 20 to 10 power minus 3, है ना, 20 to 10 power minus 3, that becomes 2 into 10 power minus 2. ठीक है, so please be careful about this. And why I am not selecting, मैंने आपको बताया था, देखो आप अपना axis, आप अपना reference x is equal to 0, you can select wherever you want, but the thing is, if the profile is symmetrical, it is easier for us to calculate the things. If the profile is not symmetrical, and I'm telling you that in this case, the conditions on the two sides of the wall are not same, and therefore the profile will not be symmetrical. If the profile is not symmetrical, in that case, there is no benefit of selecting the x is equal to 0 in the mid plane, so I have taken x is equal to 0 here. Okay? General equation of heat conduction. This is one dimensional, steady state. So, you know what we are left with, d square t by dx square plus qg by k is equal to 0. ठीक है, equation same है ना, starting equation is same, but because the boundary condition are different here, the final profile will be different. ठीक है, so let us solve this equation. I think we have done this already, right? So d square t by dx square is equal to, so dt by dx is equal to minus qg by k into x plus c1, correct? And t is equal to minus qg x square by 2k plus c1x plus c2. This we already know. In the previous cases, you know that I told you that this is a parabolic profile, and if the parabola has to be symmetrical, the c1 must be 0, x part should not be there. But in this case, don't say कि sir यहाँ भी c1 0 ले लो, यहाँ symmetrical profile नहीं बनेगी. I can't take c1 is equal to 0. Definitely c1 will be non-zero. What are the boundary conditions? At x is equal to 0, t is equal to 160 degrees Celsius. Fine. So put x is equal to 0. You got that C2 is equal to 160 degrees Celsius. Correct? Fine. Okay. At x is equal to, यहाँ अगर आपने 20 लिख दिया सारा क्वेश्चन गलत हो जाएगा. At x is equal to 2 into 10 power minus 2 meters, right? T is equal to 120 degrees Celsius. देखो अगर यहाँ पे मैं आपको ये जनरल डेरिवेशन भी इसकी कराई जा सकती है, बट कोई फायदा नहीं है. आप इस प्रॉब्लम को सॉल्व करके जो चीजें सीखोगे वो आप डेरिवेशंस में नहीं सीखोगे, है ना. मैंने इसलिए जो डेरिवेशन करा है वो सिंपल केस का लिया था. न्यूमेरिकली सॉल्व करना थोड़ा सा कॉम्प्लेक्स होगा डेरिवेशन इसका, थोड़ा ज्यादा t1 t2 न जाने कितना सारा टर्म्स बन जाएंगे, है ना. आप कर सकते हो, जो फाइनल रिजल्ट आएगा आप उसको कभी भी याद नहीं रख पाओगे वैसे भी. ठीक है, तो इट इज बेटर टू अंडरस्टैंड दिस सिनेरियो विद द हेल्प ऑफ अ न्यूमेरिकल प्रॉब्लम. ओके, सो 2 into 10 power minus 2 meter and t is equal to 120 degrees Celsius. ठीक है, क्या करना है आगे इसमें, बाउंड्री कंडीशन को यूज करते हैं. लेट अस यूज दिस कंडीशंस. In the same equation, you can write this t is equal to 120. Let us check the units. Minus 80 megawatt. So minus 80 into 10 power 6 watt per meter cube into x square. What is x square? Into 2 into 10 power minus 2 square. ध्यान से put करनी है values. Divided by 2k. 2. What is k into 200? ठीक है. प्लस c1x, c1 पता है क्या, c1 तो नहीं पता है. ओके, प्लस c1 इंटू 2 इंटू 10 पावर माइनस 2 प्लस c2 पता है क्या, हाँ c2 पता है, c2 इज 160. ओके, फ्रॉम हियर विल गेट द वैल्यू ऑफ c1. लेट्स सी, काफी चीजें कैंसिल हो जाएंगी. लेट्स सी व्हाट वी आर गेटिंग. सो दिस इज 2 इंटू 10 पावर माइनस 2, दैट बिकम्स 0.02, राइट? 0.02 स्क्वायर एंड दैट मल्टीप्लाइड बाय that multiplied by 80 and divided by 400. So that becomes 80. Okay, with a negative sign or positive sign? Negative sign, I think. Yeah, 120 is equal to minus 80 plus 0.02 C1 plus 160. देखिए क्या बनेगा ये. 160 minus 120 will be 40, and 40 minus 80 will be minus 40, right? Minus 40 is equal to minus 0.02. So C1 will be 40 divided by 0.40 divided by 0.02 is equal to 2000. So C1 is coming out to be 2000, right? Now you have C1, you have C2. Always you can write the temperature profile. So T is equal to, what is the temperature profile? दिस माइनस क्यू जी बाई 2k, C1 मिल गया, x मिल गया ना, T इज इक्वल टू माइनस क्यू जी, सो दैट इज माइनस क्यू जी एक्स स्क्वायर, है ना. सो 80 इंटू 10 पावर 6, 80 इंटू 10 पावर 6 बाई 400. डोंट राइट दिस, वो L स्क्वायर लिखना था मैंने तो लिख दिया, ठीक है ना. ओके, दैट मल्टीप्लाइड बाई एक्स स्क्वायर प्लस 2000x प्लस 160. आई थिंक दैट इज द रिलेशन. ठीक है, ये देख लेते हैं भाई ये कितना आता है. That becomes minus 2 into 10 power 5, 42, yeah, minus 2 into 10 power 5 x square plus 2000x plus 160. That is the temperature profile. That was the first part, that we have to determine the temperature profile. तरीका वही है, ठीक है. चीजें कहाँ गलती होंगी, you will forget to convert this, right? और कहाँ गलतियां होंगी, बाकी अगर आप इक्वेशन ही भूल गए, यहाँ पे कुछ गलती कर दी आपने. ओके, दैट इज द टी. द सेकंड क्वेश्चन सेज दैट द लोकेशन एंड द वैल्यू ऑफ मैक्सिमम टेम्परेचर. सो फॉर मैक्सिमा यू नो दैट dt by dx must be equal to 0. So what is by dt by dx? You can calculate dt by dx here. So dt by dx comes out to be, dt by dx is equal to minus 4 into 10 power 5x and plus 2000, and that has to be 0. So x is equal to 2000 divided by 4 into 10 power 5. Let's see, this answer will be in meters, of course. So 2000 divided by 4, and it is coming out to be 5 into 10 power minus 3 meters, which means 5 millimeters. So 5 millimeters from where? From x is equal to 0 means the maximum temperature. Now this is a very very important conclusion. ये मैं आपको थ्योरी से बता सकता था, बट वहां उतना मजा नहीं आता, है ना. This is a very very important conclusion, that the maximum temperature will be 5 mm away from the 160 degree Celsius wall towards, of course, inside the wall. Or you can say that this is, ये कितना है 10 ना, और 15 mm away from the 120 degree Celsius. I'm measuring all the distances from here, so my answer will be 5 mm, right? Now it is if it is a kind of MSQ, even at a distance of 15 millimeters from 120 degree Celsius wall into the 120 degree Celsius wall into the solid, again it will be the same point. So there will be a maxima here. There will be a maxima here. ये maxima इससे ज़्यादा ही होगा, of course. So there will be a maxima here. So what is the important conclusion here? The important conclusion here is, okay, it seems like maxima यहाँ पे आ गया. So ठीक से बना लेते हैं. Okay, आप बना लेना इसको कायदे से, ठीक है. लीनियर नहीं लगना चाहिए. It is non-linear profile, of course. You can see the equation. It is parabolic, but it is not symmetric about the mid plane. Okay, the important conclusion, that if the two sides of a wall are maintained at different temperature, then maxima will always exist closer to the higher temperature wall. ठीक है, ठीक है. In these conditions we have concluded, right? We can conclude here. Let me write that when the wall is maintained, ऑफ कोर्स जनरेशन वगैरह भी होगा, ये सारी इसी कंडीशन के लिए लिखवा रहा हूं, और कहीं मत लगा देना. इवन k शुड बी कांस्टेंट. ऐसा कुछ भी बदल दिया देन डोंट यूज दिस. ओके, व्हेन द टू वॉल्स ऑफ द सॉलिड, व्हेन टू वॉल्स ऑफ द सॉलिड आर मेंटेन्ड एट डिफरेंट टेम्परेचर, ये कंक्लूजन मुझे आपको देना था जो मैं न्यूमेरिकल की हेल्प से देना चाह रहा था. ठीक है, व्हेन टू वॉल्स ऑफ द सॉलिड्स आर मेंटेन्ड एट अ डिफरेंट टेम्परेचर, are maintained at a different temperature, then the maxima exist. Then the maxima exists closer to the higher temperature wall. Closer to the higher temperature wall. That is a conclusion. लिख लो. कोई भी चीज बदल गई तो वहां यूज मत कर लेना कि अगर टेम्परेचर का फंक्शन हो गया. ठीक है. वन मोर थिंग, इन दिस वॉल ओनली एनर्जी इज बीइंग जनरेटेड एंड देन इट इज कंडक्टेड आउटसाइड. ऐसा नहीं हो रहा कि इन भी हो रही है एनर्जी कहीं से, अगर वो इन लग जाएगा तो और प्रॉब्लम है, ठीक है, आई विल कम टू दैट आल्सो, ठीक है। सो नोट डाउन दिस वाज द टेम्परेचर प्रोफाइल एंड देन वी हैव दिस मैक्सिमा एंड मिनिमा। व्हाट इज द नेक्स्ट? What is the rate of heat transfer at the left face? Means, okay, let's talk about that. So T को तो लिख लिया मैंने, dt by dx कहाँ है? dt by dx भी लिख लिया है, okay. So now I want to calculate the rate of heat transfer on the left face, correct? The rate of heat transfer at the left face. Left face means I have to calculate Q at x is equal to, left face is this 0, right? See, I have considered this direction as the positive direction, है ना, क्योंकि 0 से मैं कहाँ जा रहा हूँ, 2 into 10 power minus 2, so this direction is positive, okay. So Q is equal to minus K into A, area given है क्या, 20 mm thickness, area तो given नहीं है, ठीक है. So we have to calculate flux, no, we have to calculate rate, okay, that's nice. You can take area to be unity if area is not given, because 20 mm thick plate, uniform rate of heat generation, okay, not a problem. आप एरिया को यूनिटी ले लो, ऐसा गेट में नहीं करना है, बट वी हैव टू फाइंड सम वैल्यू, ओके. माइनस के ए dt by dx at x is equal to 0. That is the meaning of q at x is equal to 0. So minus k, what is minus k? Minus k is minus 200. Minus 200. I am deliberately taking area to be 1. Then I'll take everywhere. I mean, my answer will be for unit area, don't worry. Okay, so minus 200 into 1. And what is by dt by dx at x is equal to 0? Put x is equal to 0 here, it will be 2000. So that becomes negative 4 into 10 raised to the power 5 watt, correct? Watt per meter per Kelvin, so 2000 Kelvin and Ka dt by dx, okay, that was dt by dx. What do you think, this 2000 should have some units or not? This 2000, C1 and C2, are they having some units? Of course they have. Right, of course they have units. So that is the value of Q. What is the role of negative sign? Negative sign means from this wall Q is leaving in this direction. यहाँ इस क्वेश्चन में इतने सारे कंक्लूजन्स हैं कि इसको 1 घंटा सिर्फ इसी क्वेश्चंस पे बात की जा सकती है, ठीक है. Q is negative means from the left wall of 160 degree Celsius temperature, Q is leaving, heat is leaving in this direction. Let's talk about the Q at the right face. आपने ये भी पढ़ा मुझसे कि लेफ्ट साइड से जितना हीट निकलेगा उतनी हीट राइट साइड से निकलेगी, बिकॉज है ना, सिमेट्रिकल. बट क्या ये सिमेट्रिकल है क्या? नहीं. इफ इट इज नॉट सिमेट्रिकल, सो ऑल दोस कंक्लूजंस दैट इफ दिस इज द मिड प्लेन, you are calculating Q at distance from the mid plane on this side and at the same distance from the mid plane on that side, Q should be same. That is only valid if the profile is symmetrical. यहाँ Q same कैसे होगा? dt by dx ही same नहीं है, तो Q same नहीं होना चाहिए. of course आप देख लो, Q at x is equal to L is equal to minus K A dt by dx, right, at x is equal to L. आपने ये भी पढ़ा था कि if the profile is symmetrical, then at the mid plane act as a insulating surface and the value of Q must be 0. यहाँ mid plane पे insulating surface नहीं आएगा, value of Q won't be 0. अगर आपका यहाँ पे insulating surface आएगा तो कहाँ आएगा? 5 mm पे आएगा. Okay, so at x is equal to L. So let us put the value. L is okay, I'll write down here minus 200 and area, let's take 1. dt by dx is this, x is equal to L. So that means, okay, that means minus 4 into 10 power 5 into 2 into 10 power minus 2. काफी कुछ हो गया. minus 4 into 10 power 5 x plus 2000 है ना, plus 2000. Let's see what we are getting. Of course it will be positive or negative. Let's see. This is 8, okay, minus 8, 10 power 5, so into 10 power 3, so minus 8 into 10 power 3, so minus 8000. I think I'm correct. Yes, plus 2000, right, and that multiplied by minus 200, right. It is coming out to be, with a positive sign, it is coming out to be 1.2 or 12, 1.2. Let's write 12, don't worry. 12 into 10 raised to the power 5, because it is, I'm writing this one with respect to 10 raised to the power 5. So this is also 12 into 10 raised to the power 5 watt. Okay? So this is the Q leaving from the right wall, and the positive sign shows that of course it leaves in this particular direction. Now you'll ask, sir, इधर से 4 into 10 power 5 and in this direction 12 into 10 power 5. How is it possible? Yes, it is possible, of course. What do you think? The energy leaving from the left face, which is 4 into 10 power 5, negative sign indicates the direction only, and from the right face, which is 12 into 10 power 5, if I add them, what I'm going to get? Think about this. If I add the energy leaving from the left face of the wall and from the right face of this solid slab, in that case, if I add both of them, what I should get? I should get, because this is steady state, right? So the energy leaving from all the surfaces, whether left surface or right surface, the energy leaving must be equal to the energy generated. Because energy generated in the solid wall is leaving, and that is why we are having steady state. So energy leaving कितनी है? 12 into 10 power 5 and 4 into 10 power 5. What is the total energy leaving? Don't subtract, add them, because that is the energy leaving in opposite direction. बस direction है, ये है तो energy ना. Total energy leaving is 16 into 10 power 5 watt. You can check what is the total energy generated. Don't say कि sir total energy generated is 80 megawatt. No, that is per unit volume. What is the total energy generated in this entire body? You will find that that will be equal to 16 into 10 power 5 watt. Correct? Next part is to calculate Q at the, I think, mid plane. Don't take x is equal to 0. The x is, will be equal to 1 mm here, 1 mm, 10 mm here. So 1 into 10 power minus 2 meter. So in the dt by dx, you can put the value of x is equal to 1 into 10 power minus 2. I hope आप वो कर पाओगे, कोई ज़्यादा मुश्किल काम नहीं है. मैंने आपको करके बता दिया कि q कैसे सॉल्व होगा. Don't think कि मिड प्लेन पे जो q की वैल्यू होगी वो 0 आएगी, ऐसा नहीं होगा. मिड प्लेन पे q की वैल्यू 0 नहीं आएगी, ठीक है. आप सॉल्व करके देखो, and you should also verify that the heat generated in this entire volume, means heat generated per unit time, should be equal to 16 into 10 power 5, because heat leaving the body is equal to sum of all the heats leaving the body is equal to 16 into 10 power 5 watt. Seventh problem देखते हैं. Again on the concept of generation of energy within a solid. The question says that an electrical resistance wire 2.5 millimeters in diameter. So D is equal to 2.5 mm. 2.5 millimeters in diameter and 0.5 meter long. So L is also given, that is 0.5 meter. ठीक है? Has a measured voltage drop of 25 volts for a current flow of 40 amperes. So delta V or V is 25 and current flow is 40 amperes. So I is 40 amperes. ठीक है? कुछ पहले जैसा ही है. The thermal conductivity of the wire material is 24 watt. So K is 24 watt per meter per Kelvin. अभी तक सब कुछ standard units में except this millimeters. और determine the rate of generation of thermal energy per unit volume is QG within the wire. QG determine करना है. So तरीका शायद पहले भी कर चुके हम लोग. Just first of all calculate P, that is V into I, that is 25 into 40. This P will be in watts. So that becomes 1000 watt. Right? 40, 1000 watts. Yeah, correct. Now that what we have to find QG. QG is watt per meter cube. So what is the volume? So QG is equal to 1000 watt divided by volume, which is pi r square h. So what is R? 2.5. So that becomes 1.25 mm. So R is 1.25 into 10 power minus 3 square multiplied by 0.5. This will be in meter cube. So watt per meter cube. Let's see what is the value. 0.00125. That is 1.25 into 10 power minus 3 square into 0.5 and multiplied by pi. 1000 divided by this is equal to 407436. Let me check this answer again. P is equal to V into I, so 25 volts it is, right? 25 volts and 40 amperes, so 25 into 40, which gives you 1000 watt. And the volume, and this volume is pi r square h, correct? Yeah, so pi r square h. Okay, everything is fine. Pi square L is, everything is fine. So let me do this calculations again. 0.00125. That becomes 1.25 into 10 power minus 3, right? Square multiplied by 0.5 and that multiplied by pi. Yes, 1000 divided by this gives you, it is quite high, 407436654.3 watt per meter cube. You can express this as megawatt or kilowatt per meter cube, of course, in whatever units you want. The question is now, the maximum temperature in the wire if the surface temperature is kept at 650 Kelvin. So, surface temperature is given to you, maximum temperature is asked, so which formula can be applied? That is Tmax minus 650 Kelvin. So, that is the surface temperature is equal to Qg, which is this multiplied by R square, right? So, let me write this 407436654.3 multiplied by R square by 4K, right? So, what is R square? R square is 1.25 into 10 to the power minus 3 square divided by 4K, correct? So, 4 into K, which is 24, correct? So, let's see what is the result. 125 square and that multiplied by 407436654.3 and that divided by 4, that divided by 24. 6.63 plus 650 Kelvin, the answer I am getting is 656. The maximum temperature is 656.63 Kelvin, which will be at the center of the wire, right? So, current agar flow kar raha hai, of course, you can always calculate that what is the energy generated, but be careful that the energy generated which you are calculating is energy generated per unit volume or energy generated per unit time. If they are asking you energy generated per unit volume, in small qg we have to find. आप अगर एनर्जी जनरेटेड पर यूनिट टाइम फाइंड कर रहे हैं, देन दैट इज समथिंग ईजी, जिसको हमने ईजी बताया था, एंड दैट शुड बी यूज्ड इन एनर्जी बैलेंसेस. Energy generated is equal to energy living, like that. So this question and previous question, they are almost same, but previously we were dealing with the insulation also. In this problem there are no insulation, there is only the solid body. So the center line temperature can be calculated if the surface temperature is known. Agar surface temperature known nahi hoga, in that case the heat transfer coefficient will be provided to you, or and that medium temperature will be provided to you. Fine. So these all of them are almost similar kind of problems. Fine. Eighth question is here. Diagram dekho. It says there is a composite network, right? Heat flows through a composite slab as shown below. The depth of the slab is 1 meter. Depth means its thickness into the board is 1 meter, and the K values are in watt per meter per Kelvin. The overall resistance is being asked. Okay. So you have this kind of wall. What is the meaning of this sign? That the length of the wall is not to scale, so no need to make this shape. We have this kind of composite wall. So it's a kind of series plus parallel combination. You can see here. This is the wall, and then this is the wall. Okay. Heat flux is in the direction from left to right, and the depth into the board is given as 1 meter. The thermal conductivity of this material is K is equal to 0.02, and this length in the direction of heat transfer is 0.5 meter. आपको उसी डायरेक्शन से मतलब है, उसी लेंथ से मतलब है, in which आपको उसी डायरेक्शन की लेंथ से मतलब है जिस डायरेक्शन में हीट ट्रांसफर हो रहा है, right? And then this height is equal to 0.5 meters, and the total height is equal to 1 meter. ठीक है? The value of K is 0.1 for the material at the top, and the value of K is 0.04. K is 0.04, and this is given as 0.25 meter. Of course, this is I told you that you have to treat heat transfer resistances in the same way as we treat the electrical resistances. If they are connected in series, then we simply add them, right? We can say that these two resistances, the resistances of heat transfer here and the resistances of heat transfer here, they are connected in parallel, and the equivalent resistance of this body and this resistance, they are connected in series. So what is the resistance? L by Ka. So if you consider this network as a combination of resistance, this will be the case, right? So we have to find the equivalent resistance in this case. Okay, now? So what is the length? 0.5. Okay, so yeah, what is the length? L by, what is this resistance? This resistance will be L by Ka, so that is 0.5 divided by, we have the options also, you can see the options. Okay, so 0.5 divided by 0.02 multiplied by A, area is always taken in the perpendicular direction, so area should be this multiplied by this. And what is this length? This is 1 meter, and that into that area is also 1 meter, so area is 1 meter. This is one resistance. If you talk about this resistance, the length is 0.25, so 0.25 divided by K, which is 0.1. Now what is the area? Don't take the complete area for this much, only this much area should be required. So depth is 1 and this height is 0.5, so the area becomes 1 into 0.5, that is 0.5 for this resistance. This is 0.25, K value is 0.04, and area is again, this is 0.5 and depth is 1, so that is 0.5. So if you write the resistances, it will be 0.5 divided by 0.02, 0.02, the value is 25. So the values are 25, 25. This value will be 0.1 into 0.5, and 0.25 divided by this is 5. Okay. This value will be 0.04 into 0.5, and 0.25 divided by this is 12.5, right? So 5, 12.5, these are the values. Okay, so if you consider these resistances, you know that these are connected in parallel. For parallel resistances, what is the formula for effective resistance? If you remember, it is product by sum, or if you don't remember, then just apply the basic rule. So आप बिल्कुल अगर इसको बच्चों की तरह करना चाहो तो 1 by R equivalent or R total for the parallel branch will be 1 by 5 plus 1 by 2.5. So that will be sum by product. So reciprocal will be product by sum, right? So I'll be taking product by sum as the equivalent resistance. So 12.5 into 5, and that divided by sum, which is 17.5. 3.57 for this this parallel network, and 3.57 plus 25 is 28.57. So 25 plus 3.57 is the total resistance, which is 28.57. The option C here, which is 28.6, is the most closest answer. Okay? That was again a simple but slightly different from the previous problems. Okay, so note down. क्वेश्चंस इस तरह के मैकेनिकल में भी आ चुके हैं, केमिकल में भी आ चुके हैं, है ना? मैंने आपको ये कंडीशन डिस्कस भी की है कि इन दिस कंडीशन once a student asked me that, sir, if the parallel bodies are having different thermal conductivities, how the temperatures can be same? In that case, we can have different heat fluxes. We are maintaining different same temperature somehow. Somehow, with the help of some kind of arrangement, I am maintaining similar temperature on the right side of the wall. But if K is different, then ultimately the heat flux through the body will be different.